Good afternoon, dear colleagues. I have been working at Kadastrsyomka for many years. My company has been on the market for more than 10 years. We provide laser scanning, digital aerial photography, forest management, and so on. Recently, we had a request from a large Russian research facility of pipeline transportation. The problem was that the length of pipelines owned by Transneft is over 70,000 kilometers. Since the petroleum runs through pipes when heated, there are problems with exogenic processes. It is necessary to continually monitor the pipelines. As I mentioned earlier, the length is very big, and it's not possible to provide measurements with ground infrastructure. So they selected an area of interest and wanted us to help them establish the accuracy of coordinates of the sites and areas, identify relief forms under exogenic processes, define minimum sizes of identified points on laser images. Accuracies that they provided us with needed to fit 5 centimeters in the position and 5 centimeters in height. We planned 2 flights, one 200 meters, the second 400 meters. The point density should be 1524 at 200 meters and 9 to 10 points per 1 square meters at 400 meter. And the accuracies in the position and the plan are provided here. At least 5. So first we did flight planning. The area of interest was 40 kilometers. We used aerial laser scanning and digital aerial photography. There were several companies that were involved in the project at different stages, including for interpretation of data. This is a tentative flight route, 2 ground stations 20 kilometers away from each other. The swath at 200 meters was 200 and at 400, 400. Even though the width of the clearing was 80 meters, so we included several meters of the forest. So we obtained orthophoto plan, 3 centimeters. This is easily identifiable, even the number plate. The people and the digital surface model. This is one of the repair facilities.
Right here you can see that the density of points is about 100 here. It's because we had a lot of overlapping swaths and paths. We had to look at other things as well. At the time, when we did aerial photography acquisition, people from Transneft had a testing ground where they assessed the accuracy. Those were figures, 8 octagons and squares. Those were power lines with special coordination, and the height or altitude meters, and also some pipelines here. As a result, and they submitted a table that we had to fill in. based on cameral measurements. We did all the measurements. Here you can see the dimensions that we measured in camera. And the next step, we came up with this table. To your left, do we have a pointer? No pointer, okay. To your left, you can see the results that they measured in field. And to the right, we have in-camera measurements. We used orthophoto to measure plane coordinates. And the difference was less than 5 centimeter on the ground, and in height we had some misses, like for instance on the 12th figure we were wrong with the height, but the RMS was less than 5 centimeters. Also, some of the pipeline goes underground, and it's very difficult sometimes to identify its real height, and they specifically mounted the height devices. They attached the pipeline to that, and with a plate on top. The slide shows that this red dot is the dot measured through on-ground method through a GNSS image acquisition, and these are the 3 points reflected from laser scanner. The RMS error was 5 centimeters here. I'm sorry, RMS error was 1 millimeter here. Also, we checked whether we can contour the power lines and their deviations from vertical structure. Here you can see power lines measured by tachyometry through field exploration, and in camera we measured it based on the laser reflection with 0.4 degree deviation. The identification of relief forms, field methods using tachymetry. We measured the protection embankment for the pipeline, and here the height difference was 5 centimeters. The green points are the points measured in field, and the orange dots are the field reflections acquired by laser. Then this information had to be systemized, accumulated, and dynamically monitored by aerial laser scanning that they have to plan to do every year to assess exogenic processes and for quick decision making. These are fragments of the laser scanning classified for different textures. Also, based on the points of laser reflection, one can easily analyze the surface. This is the light and shadow model, digital model. This is the general height model. This is the exposition elevation model, which you can see how it changes. We'll look at the condition of the embankments and the roads here, and the exposition and sloping map. Also, when we did aerial laser scanning, we can make decisions on removal of dangerous trees that can threaten, say, power lines or pipeline. We can project its growth rate for 5 years, what happens if these trees fall over, and then we can cut them up earlier. In other words, we can clearly project the actual height of trees, and we drew a map of these trees, of which one of them can threaten our pipelines. As a result, we came up with this map, which helped us cut down the dangerous trees. Conclusions. The accuracy of identification of the points on site based on Landsat is not higher than the originally designed parameters. The technology of aerial scanning allows us to monitor the relief which has formed because of exogenic processes. The SAT technology allows us to monitor other parameters as well. And in conclusion, the Transneft company decided to equip itself with this technology, and then every year we're going to monitor all our sites using the aerial laser scanning technology. Thank you. That will be it. Thank you. Dear colleagues, are there any questions? Hello, Aleksandr Chikurin, company Rakurs. Tell us please, the selection of aerial laser scanning technology was something that your customer wanted, or did you yourself decide that this technology would be better than photogrammetric technology here? C. The technology was tested by 2 companies. I will explain why we opted for the laser scanning, because it was interesting for us to see not only the visual parts but also the ones covered by trees. And they told us that we dug up a pit over there, find it by digital terrain model. We were wrong by 10 centimeters only. It was 90 centimeter wide. We calculated 82 centimeters or something. And the 2 scanners also, they were quite attentive about that, because there are scanners with the rotating prism, and also it's like from Regal, and the rotating mirror scanner like from Leica, and they were quite concerned to get this information. That's why both of the scanners lay within the same parameters. Bolsunovsky, Aleksandr, Sovzond. My question is less about technology. You said that Transneft decided that laser scanning is going to be applied for all sites of Transneft. I still guess that there are too many of them to be covered by all of it, and they're prepared, in your words, to do regular monitoring by laser scanning to address these goals. Yes, they're prepared to do that, but they still don't know whether they are going to use their own laser scanner or they're going to change providers all the time, because all the work will be done based on the competitive basis, and they cannot guarantee that annually the same company would win the tender. I'm sure that they will get results every year confirming previous year's results, but they still don't have budget to buy their own laser scanner. I understand that everything is based on financial constraints, because even if we look at the power lines, a lot of work is being done, but in real life, regularly, not even monitoring, but just image acquisition of power lines in Moscow district, the well-known company is doing this, but they're not monitoring, but they're more like within 5 years' time acquire images of all the power lines of Moscow district. And Transneft, I think it's not Moscow district. Well, they're just testing this technology, and they fully realize that to change a provider here would be wrong for such a technology. But on the other hand, to guarantee that the same provider will provide this service is also a far-fetched conclusion. Then the last question, simple one. Tell us please, Transneft, to change the providers and not to risk the results, do they have some internal technical document on technologies? Not yet. They had the terms of reference, which was quite detailed and strict, even in terms of the work plan, but the processing technology, their task was for acquisition but without processing. They didn't have it. As long as it is important for us now, I told you that the norms, provisions of our federal law since 2018 will cancel the norms of all the other normative technical documents, and if some company adopts a normative document on technologies, we need to look at them, how they work and operate. Okay, thank you very much.